Okay, and this is the last section in this chapter here, and you can see how everything is really kind of related. So it seems like there's a lot to remember, but especially with the graphing calculator, there's not as much as it seems. So this last one's about solving equations using combinations of unfamiliar functions, and you really already have done most of this before. It's just using your calculator to solve things. Now, some things can be solved algebraically, and that's the best method to do. Algebraic, logarithmic, or trigonometric techniques, because they will give you the most exact answer. They will give you an exact answer, whereas graphing does not. So, for example, we could solve this first example here using the calculator. We would type those powers in. Whenever you have a fraction power, you do want to put it in a parenthesis, but we could type that in. Or we can do a substitution example, or substitution to make it into something similar to something we've done before. So let's let y be x to the 1/3. And let's take this equation here, and let's actually think of it as being x to the 1/3 power squared. Powers are powers you would multiply, so that would be the same thing as to the 2/3 power. 7x to the 1/3. And let's move the 3 to the other side. Now we could do our substitution here. We could replace the x to the 1/3 with y. So that's going to give me 2y squared plus 7y plus 3. Sorry there, that was my phone. We're going to factor that now. Or we could use the quadratic formula or some method like that, but that could still give me a decimal. So let's try to see if we can factor it. I'm going to look to see what would I multiply there to get me a 2y squared. Well, that's just going to be a 2y and a y. What would I get to multiply here to give me a 3? Well, it's a 1 and a 3. Not completely sure where the 3 would go. If we put the 3 here and the 1 here, if we multiply that back out, I'm going to get a 2y and a 3y, which does not add to give me a 7y. So let's switch it around here and make it be a 3 and a 1. If I multiply that back out, I do get the 2y squared plus 7y plus 3. So that's my factorization. Now, if I solve these little factors here, I'm going to get -1/2, and I'm going to get -3. But that's not my answer because that's y, and y is really x to the 1/3, and I'm trying to solve for x. So x to the 1/3 is this. X to the 1/3 is that. Now remember, a 1/3 power is the same thing as a cube root. So if you want to get rid of a cube root, you're going to cube. So x is going to be -1/2 to the 3rd power, which would be -1/8. You cube the top and cube the bottom. Okay, this one would be x is equal to -3 to the 3rd, which would be -27. Make sure when you're doing negatives to powers that you put them in parentheses so you can be sure that the final answer that you get is your final answer. Sometimes if you don't put them in a parenthesis, you end up with a negative when the answer should not be negative. Okay, so for these last ones here, we're going to put these into the calculator. These are not things that we could solve by hand. So we're going to put the left side into, say, our y sub 1 and our the right side into the y sub 2. Graph the functions. If you have some idea of what the function looks like, it's going to help you know whether you're seeing, again, a good picture. If you are doing something in a trig function, which we'll be doing here at the end, make sure that you are in degree mode and that you have a good window for that. Find the intersection point or points. The x coordinate is going to be your solution, and then check those to see if they work. So here we go. So first one here, 2x. Now 2x would be a line, okay? The next one is going to be 2 to the x power. Now that's an exponential function. My base is a number greater than 1, so this is going to be an increasing function. Okay, so here we go. There's my line. And here comes my curve. Okay, now it's a little bit hard to see what's going on here, so what I'm going to do is I'm going to zoom in. So let's go to zoom and in. It looks to me like up here, the red graph goes on the other side of the blue graph, but I can't quite tell. So once you get to where you want to zoom in, hit enter, and the graph's going to redraw. Wow, even zooming in, that's hard to see. There are two answers. It's crossing right here, and it's crossing right there. Okay, so to get those numbers, remember you're going to go to calculate, intersect. Okay, so move to where you think one of those intersection points are. Hit enter 3 times. Okay, and then one of my answers is 1, 2. So remember the answer is actually the x value. So x equals 1. And then same thing again to find the other one. Okay, so this time I'm going to come up here. And 2, 4. Now, when I was talking about having some idea of what the graphs look like, let me go back to the original graph. You know that you have a line, and you know that you have this exponential function curve. So you should have an inkling that the graph could go on the other side of that line and then come back and hit it. That's why you would know to possibly zoom in there, because otherwise you would not see that. Okay. Okay, so the next one, we've got a square root and we've got a line. So again, the same kind of thing could happen on this, because a square root function does have a curve in it. So with the square root of x, and then we have 2 minus x. Okay, and I hit graph here. So there's my absolute value. I'm sorry, my square root. And there's my line. So the way this line is going, it's only crossing that in one spot. But if the line had been something more like, well, I guess even like that, it only would have crossed it once, just because of the arc of that square root, I guess. So calculate, intersect, enter, 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 1, 1. Okay. So my answer would just be 1. And both of these would be very easy ones to check. Okay, C. Okay, 1 over x minus 1, that's the rectangular hyperbolic function, or the rational function, whatever you want to call it. And then the other one, sorry, 3 to the x is another exponential function like on A. So we have 1 divided by x minus 1. And then here we have 3 to the x. Okay, so we hit graph. So here's my reciprocal function. Looks good. And then here comes my other function. Okay, so definitely we're crossing there on the right-hand side. But on the left-hand side, I'm not really sure what's going on there. So we'll maybe need to zoom in there in a minute, but let's go ahead and do the one that's obvious. So we've got an intersection. Okay, now in this case, I need to get to the other side. If I continue going to the right, eventually we're going to jump over to the other side. So I can't get quite exactly where they cross, but I'm pretty darn close. Okay, so there's 1.25 if we go 3 sig figs. So x equals 1.25. Okay, now just trying to think here. If we plug in a really big negative number, which is what's going on here, okay? So let's say we plug in a big negative number, say negative 10. If we take 1 over, well, let's go even bigger. Let's plug in negative 1,000. I'm going to have 1 over negative 1,001, which is essentially 0. When I take 3 to the negative 1,000 power, that's going to essentially also be 0. What's happening is these are coming to the same asymptote line, but they're never touching the same asymptote line, and they're coming at it from different sides. So if I take out the blue here, just for a minute, and maybe it's not obvious from looking at this graph, but the red graph is actually starting on the upper side of the x-axis. And then when I drew the other graph, it's coming from the lower side. So these are never going to touch. They're essentially becoming 0, but they're becoming 0 on opposite sides. So this one just has one answer, and that was where we crossed there on the right-hand side. And that's where, again, having some idea of what the graph looks like is helpful, because I couldn't quite tell from the calculator. All right, so the last one here, this is a trig function. Let me get it typed in, and then we'll look at the things that we need to look at to make sure that we're graphing this correctly here. So this is going to be 2 cosine of 2x. So we can go ahead and close the parenthesis on that. And then 1. All right, so I need to make sure I'm in degree mode. I am not. So we're going to come down here to degree. And then it says here that my window needs, or my domain is 0 to 360. So 0, 360. And let's go by, let's go by 45 degrees. I know that's going to kind of seem weird, but that's a pretty good interval to use when you're dealing with degrees. It really honestly doesn't matter, because we're going to be using the calculator to solve this anyways. So let's hit graph here. So this is the first graph. And here we go. So this one's going to have a couple different answers here. So we've got 1, 2, 3, 4 answers on this one. So we're going to go to calculate, intersect. So let's zoom back over here. Okay, enter, enter, enter. So 30 degrees. That's in terms of degrees here, was our domain. So we go back here to intersect, and now we go back over here again. It is helpful if you start on the left-hand side, even though it takes you a while to get there initially. It makes finding everything else a little bit easier. Okay, so then we have 150. I'm going to jot these down over here. We had 30 degrees, 150 degrees. Okay, keep going. Enter, enter, enter. Okay, 210. Oops, wrong thing. Okay, 210. and 330. Now, all of these graphs were fairly pretty in the fact that I could see everything on the graph at once. I did have to zoom in and again think about just the general shape of the graphs. But otherwise, if it looks to you like you're not seeing, like you can see that they intersect off the screen, then change the window. If it looks like it's further to the right, then make your X's be bigger. If it looks like it's further up, then make your Y's be bigger. You really can't tell necessarily when you graph something what your window is going to need to be, unless you're lucky enough on this last one here where they actually give you your domain. They give you your X values. Okay. As always, let me know if you've got questions about the calculator. Sorry there about the screen glitching out if it was doing it on your end.